look at how to measure stuff in physics, identify the variables, and also graph the data. So when you do an experiment, you can only change one variable or one factor at a time. For example, you only use one spring with different masses to understand the relationship between mass and how much the spring can extend. So let me draw a mass hanging on a spring. We're going to keep it the same spring but change the masses. The variables that you have in this experiment are mass and how long the spring extends. Mass is what you control, and how long the spring extends cannot be controlled. So what I mean by the controlled variable is an independent variable, and which you cannot control is the dependent variable. Now, length of spring is dependent variable. We can plot a graph. So draw the two axes, mass in versus length. I'm going to put mass on the independent variable on the x-axis and the length dependent variable on the y. Let's take a look at an example. So let me say that I've recorded the masses in kilograms and the length at which the spring extends in meters. Let's put some data. Now notice, now again, let's plot a graph. Mass versus length, x and y axes. I'm going to put a title for the graph, mass versus length of a spring. I'm going to label the axes at an equal distance, and that's how I properly label the axes. I had to break the y-axis because I didn't start from 0, but I'm going to start from 0.135. So let's go ahead and label our points, starting from the mass and then figuring out where the length will be. Notice there's a trend. Draw a freehand line, and this is called the line of best fit. It's also showing you a linear relationship. So let's talk about that. There are two types of relationships in physical quantities. One can be linear and one can be non-linear. What do I mean? Dependent variable, if it's increasing and independent variable is also increasing or vice versa, then it's called a linear relationship. And the equation, you've already seen this before, and the slope, we'll talk more in detail about the slope, rise over run. So nonlinear relationships means that the graph is not a straight line, or there's an inverse relationship. Which means that if dependent variable is decreasing versus. So graphs can, for linear relationship, how they look like, they're usually a straight line. Let's say there's an x and y quantity plotted. So to find the slope, you can identify 2 points on the line of your best fit and extend those lines parallel to the x and y axes. Parallel to the y axis will give you this length, and parallel to the x-axis will give you this length. So now label it as rise and run. So the slope can be calculated as rise divided by run. Or if you know the coordinates of the points on the graph, you can also take this equation as y2 minus y1 over x2 minus x1. By labeling the points, you can see point 1 is first and point 2 is second. Now let's talk about nonlinear relationships. So let's take an example of a brass ball when it falls through the air versus the time that it takes to fall. So when we plot this graph, the curve that we get, so as you know, so that's a non-linear relationship. So we have plotted the time in seconds versus the distance the brass ball has traveled, measured in meters. So when scientists discover relations like the ones that you have seen in the graphs, they're actually using them to make predictions, or we're using these models to accurately predict how systems are going. Here's the model that you've learned so far. Um, you can use these tools to answer questions and produce models for the physics questions that we're going to encounter later in this class.